Good morning from me. I'm in Calgary right now, and good day to you wherever you are in the world. Welcome to our first guest speaker of 2023. We're very excited. I'm just going to start with a brief introduction of Cohere for AI. My name is Ellie Evans. I work in operations for Cohere for AI, and I'm delighted that you decided to join us today for this event. A little bit about us. We are a nonprofit research lab. We're a community dedicated to contributing fundamental research in machine learning. We're working to solve some of the field's most challenging problems together. Our programs include supporting community-driven research that's working across fundamental machine learning topics. We have the Cohere for AI Scholars Program, full-time research positions in our lab, and our fireside chat speaker series. We also do technical talks and community events. And today we're delighted to host Colin, who's assistant professor of computer science at UNC Chapel Hill. And for today's event, I'm going to turn it over to my colleague, Ellie Evans. You get double Ellie today joining us today, which is a fun and rare event, to have a really great conversation with Colin. And I'm going to stop the screen share and gently fade into the background. Ellie, take it away.
Thanks, Ellie. Hi, everyone. Yes, my name is also Ellie. I'm on the product team at Cohere. Really excited to introduce our guest today, Colin Raffel. Colin is a professor at UNC, where we actually first met, and faculty researcher at Hugging Face. Before that, he was a resident and research scientist at Google Brain. Broadly, Colin's research centers around semi-supervised and transfer learning methods for ML and driving forward methods for collaborative model development. Many folks are likely familiar with his seminal work on T5, and his early research actually centered around music processing, and he's had quite an impact there. So during our conversation today, I'm really excited to learn more about Colin's dynamic career journey, really digging into the decisions, the motivation, and maybe some of the challenges that he's encountered along the way. So like Ellie mentioned, feel free to drop questions in the forum throughout our conversation, and I'll be sure to give some time at the end for those. So without further ado, Colin, really excited to have you here today.
Yeah, thanks for having me. And yeah, it's great to get to chat with you, Ellie. Looking forward to having our discussion.
Awesome. Well, I imagine many folks listening are familiar with the influential research you've done, but perhaps not so familiar with your career journey and what that's been like. So to take a step back, in the first part of our conversation today, I'd like to center on this and learn more about what motivated you in the first place to enter into research. So to kick things off, Colin, can you share a bit about what your early days were like and really how you cultivated this passion for learning and for science?
Yeah, definitely. Yeah, it's funny to think about how early to go back. The earlier I go back, the longer I'll talk. So I'll try to be brief. You know, when I was pretty young, preteen, let's say, I had this funny kit of little electronic objects with springs, and you could connect them with wires to make different things happen. I remember really enjoying messing around with that, but not thinking that would lead to any like career or anything. But in high school, I lived in a town where there was a big IBM plant, an IBM research center, and one of my friends had a dad who worked there, and this friend of mine and I both played guitar and really liked these things called guitar pedals, which you put between your guitar and your amp to make your guitar sound different, like a wah pedal or distortion or echo or whatever. And one day he mentioned to me kind of offhand that he and his dad were working on building guitar pedals together, which it never even occurred to me was possible. And that was just super exciting to me. So I started building these guitar pedals, getting excited about building like devices for creating music, even completely on the analog side, so no coding at this point. And I ended up going to a small liberal arts school where there wasn't even an engineering school. So I kind of just did it on the side. I ended up being a math major just because math was really fun and I had a really great advisor. And yeah, kind of was just learning about electronics on the go. And then by the time I was done with my undergrad, I kind of figured I should get a more formal education in the creation of music technology. So I went to this amazing department at Stanford called the Center for Research in Computer Music and Acoustics, and did a master's there where actually basically that's where I really learned to code. I hadn't really, I took one CS class in my undergrad, and yeah, learned to write code and write software for making music, and then decided I should do my PhD again in the field of research around building music technology, especially for me from the perspective of making it easier for people to make music and making it more fun, because that's what I did. And I ended up doing my PhD at Columbia with Dan Ellis, who runs one of the few labs, because he's not a professor anymore, who ran one of the few labs that works on music technology research. Over the course of my PhD, I got more and more familiar with machine learning because, machine learning to me is kind of a new paradigm for getting computers to do new things, right? If there's something that it's hard to write down in code what you want the computer to do, but you can get lots of examples of what you want the computer to do, machine learning helps you do that. And I had, these experiences that maybe many of us have had, or hopefully many of us will have, where you have a problem you care about, you have some data, you plug in a machine learning algorithm and it just kind of works and it just feels so exciting and magical. And that got me interested in machine learning for machine learning's sake. And after my PhD, I was lucky to get to do the Google Brain residency program in its first year, when they didn't really know what it should be or what it should be like. And there's a group at Google Brain called Magenta that works on music technology, and I think they were excited about having me there. I was excited about going there to just do core ML research, and managed to make that transition, started publishing at ML venues, got more and more excited about ML, but retained an interest in making machine learning more applicable to more people, and also applicable in settings where people might not have tons of resources, because in music there's relatively limited funding and resources, so there's not these like huge labeled training data sets. So that kind of ended up resulting in a focus in semi-supervised learning and transfer learning. Transfer learning ended up shifting to a focus in NLP, where transfer learning really matters. And then finally, after 4 years at Google, I started my professorship here, where I mostly work on making it easier to get computers to do new things, whether it's through machine learning, learning from limited labeled data, or more recently learning from instructions, natural language instructions. So that's the very short, long version.
Yeah, many folks I found find their way into ML from an initial love of computers or math, but it's really interesting that yours was really grounded in a passion for music.
Yeah.
I'm curious, looking back on that career journey, what were the key decisions you made in the early days of your career that you would say were critical to your success as a distinguished researcher and leader? And what were the mistakes you made as well?
Yeah, definitely. It's interesting because I'm a little bit of a nihilist when it comes to these things, because so many of my choices were a little random and out of my control, in the sense that, why did I go to Columbia to do my PhD? Well, it was because I happened to have worked with Dan, my PhD advisor, at a company that I was interning at, and I thought he was really great. And he was the only person who accepted me, and I went there, and it was great. And because he did ML, I started working on ML. And why did I go to Google Brain? Well, it was the best option for me and my partner to move to the Bay Area. Also, it was a great opportunity, in general. But there's all these kind of extrinsic factors that can influence your life. But I would say, like, in terms of having impact, to me, like I said, it's always been important to think about how can we make this technology as applicable to as many people as possible, and especially people who lack resources, right? Because so much of the development of this technology is in the hands of people who have lots of money and resources and people power and expertise. But when you have a really useful and powerful technology, to me, the exciting thing is getting into the hands of lots of people and making it possible to have impact across a broad range of applications. I mean, mistakes I've made, the big one that sticks out to me is that I think especially when I finished my PhD, I really wanted to establish myself as a machine learning researcher. And so I really prioritized projects where I came up with the original idea, and the idea was somewhat like technically interesting and challenging. And that led me to turn down opportunities to work with other people who had, in retrospect, better ideas than I did, because I wanted ownership over the project. And it also led me to have a bias towards, again, projects that were kind of like technically interesting or juicy, as opposed to projects that were just impactful, whether they were, technically difficult. And I think as a consequence of those mistakes, I tend to be a very collaboration forward person now. Like, I really like to try to work with as many other people as possible. And I like to work on projects where it's actually important that I'm there. I'm not just, joining meetings and listening to people talk. And also that really I tend to pick projects based on their perceived impact a lot more than, let's say, like curiosity or how smart it'll make me feel to work on it. But that's me. And I noticed this characteristic in a lot of researchers, a lot of young researchers. I don't think there's anything wrong with being curiosity driven or making a name for yourself, but it can limit your opportunities and impact a little bit.
Definitely, that's great advice. So you recently transitioned from your work at Google to actually a professorship role at UNC, where you lead a team of researchers. What motivated you to step into this role and make that transitions? And, in what ways has it been rewarding and fulfilling? And in what ways has it been difficult?
Yeah. So what I always tell people, and I really think this is true for me, is that professorship will be the most rewarding and fun and valuable if you really value mentorship, giving mentorship. And at Google, there are opportunities for mentorship, but they're pretty limited. My boss, who was a great boss at the end of my time at Google, he didn't really work on stuff that was very similar to me. He never really gave me any research advice. He gave me like a little bit of career advice, but I didn't really have like a mentor. Most people, they're in industry, a lot of the time their bosses aren't working to make them better, right? And in my view, a PhD especially, I mean, school in general, but a PhD especially, the goal is to make it so that your PhD student becomes a self-sufficient expert researcher by the end. And that involves helping them develop a wide range of skills. And hiring a PhD student to me is basically a contract that says, you're going to work hard and I'm going to work hard to help you become an expert researcher. And that level of mentorship is pretty extreme and can be incredibly rewarding on both sides when it works out well. And again, if you don't value that, if that doesn't give you fulfillment, then you won't really like being a professor that much, I don't think. If you really just want to be an independent contributor, no, you're working all of your own projects, and you don't really care about helping other people, improve themselves and their capabilities, then you won't like it that much. But I have really liked it, and I kind of had a sense that I would like it based on mentoring interns or undergrads during my PhD. And so that's really what motivated me to make the switch. There also are lower level things that are lower order things, I guess, that are different that I like the fact that I'm basically forced to think about what impact my work is going to have over the next 5 or 10 years. And that's, I think, relatively rare in industry. People in industry tend to have a much shorter term vision. What work can I do that'll be impactful in a year? It's rare to plan ahead that much, and I really liked that, and it kind of allows you to work on riskier and weirder stuff. And there's a lot more to say there. As far as the challenges go, the main thing is, while the PhD student or mentee, mentor, advisor relationship, I think, can be incredibly valuable and rewarding, the difficult thing is that there is a power dynamic there. And I've found in particular that with my students, it's been a little hard to get them to give me honest feedback about how I'm doing. I'm used to working with people who are kind of all on the same, we're all just kind of colleagues, right? And so hopefully there's open communication about how things are going. But it's been a little bit hard to get feedback. And also you don't really have a boss anymore. The department chair obviously cares about how you're doing, but they're not going to, keep track of you and tell you need to do this and stop doing that. So you're kind of just guessing about a lot of this stuff. And I've in talking to more senior professors, they've told me they're still guessing. So no one really knows what they're doing. But the stakes are pretty high, because if you do something wrong, you're letting your advisees down. And I feel, like I said, I have a big responsibility to my advisees. So it's hard to get feedback on how well you're doing. The reward signals are very sparse, but the stakes are relatively high. And that, it took me a while to kind of wrap my head around that. And then when I did, and I started telling people, especially more senior people, how I felt, they were like, oh yeah, totally. That's what it's like. So it's not, I don't think it's terribly unique to me. One thing I did recently that was really valuable was I asked my students to meet without me, and I gave them like 50 questions and just brainstorm together, like feedback about the lab and about me and the work we do and all this stuff. And that was really valuable. I think it's led to some like simple action items that are great, as well as some constructive changes. And actually tomorrow we're having like a high level research brainstorming session, which we haven't done in a little while. So that's been great, but it's a big learning curve. I always say that it's a lot more stressful. I don't necessarily feel I'm more stressed out, but I do feel happier.
Yeah, there's a really interesting blog post that you actually published where you talk about a lot of these challenges, like not having necessarily a vehicle for mentorship and feedback. And you speak about some of the tactical ways you've gone about approaching that challenge as an academic. And I'm sure one of the other challenges that you come across that you've actually been vocal about is working as an academic in the era of scale. Where a challenge you might come across, I'm sure, is resource constraints. What does that look like for you today?
Yeah, this is something I was alluding to a little bit when I was talking about the difference moving from industry to academia, like as kind of like a lower order thing that actually can make a difference. And I have taken on a perspective that I think of as kind of the only perspective that I can take on to survive and be successful and happy. So I wouldn't say that everything I'm about to say is true, but I would say I'm forced to believe it in order to, in order to succeed. And that is basically that if you're working in industry and you have access to a giant supercomputer and a really, let's say, really powerful models that are only, available within your institution, then the best thing for you to do, the most strategic thing for your benefit, and actually I think the benefit of the whole field, is to use that and do research at scale with giant models and kind of like really explore the limits of how well the current technology works. And because you're the only people that can do that. And we, on the other hand, in academia, who don't have supercomputers, we don't have giant models. If we think of the work that we do as inferior to that work, basically like, well, that's the best thing that we can do, but we can't do that, then we're basically doomed to fail. And to me, the role that we have as academia is to think of all of the stuff that people should do and can do and will do in industry, and not do that. Do other stuff. Do weirder research that's maybe more likely to fail, maybe more at the fringes of what seems reasonable, or do research that only matters if you don't have scale, like making things more efficient, or analyzing why things do and don't work. Or another major research direction in my group is to make it possible for large distributed communities of people to collaborate on machine learning models, which again, industry doesn't care about that. They don't need to collaborate with other people. They have enough people in their institution, enough compute resources in their institution. They don't care about it at all. And I remember when I introduced that particular research direction, one of my former colleagues at Google said to me, this is such a good idea because we would never do this. And that's exactly what I want to hear. I mean, it wasn't why I chose the research direction necessarily, but that's exactly what I want to hear. And I also think, I believe, because I have to believe that this kind of work that we do, this work that we do under resource constraints at the fringes of what makes sense or what seems obvious, is often the work that yields to the most important advances. And I have a talk that I give called on the sweet lesson, in opposition to Rich Sutton's bitter lesson that basically says methods that scale are ultimately the most successful. The sweet lesson is that when you work under resource constraints to come up with creative solutions, you often find methods that scale really well. And I give a couple of examples of this, and just to throw one out there, what's the most scalable architecture that we've uncovered? It's the transformer, right? It's just, we have this incredible property that when you throw more data and compute at it, it just gets better. And we haven't really hit the limit of that yet, I don't think. But where did the transformer come from? Well, the main architectural component of the transformer is attention. And you can actually trace attention back to sequence-to-sequence models with attention, which are recurrent neural networks with an attention mechanism. So it doesn't look like the transformer, but the attention mechanism itself, you can kind of see the genesis there. And where did that come from? Well, actually, when the sequence-to-sequence framework was introduced at Google, it was a similar work was being done at the University of Montreal. And at the University of Montreal, this was in the olden days, right? So they actually were using Theano, and Theano didn't even support multi-GPU training. So you had to use a single GPU. And they heard through the grapevine that their colleagues at Google were getting really good results on an 8 GPU machine with training an RNN in a sequence-to-sequence framework. And they were like, oh God, what can we do to match or improve over those results without like an 8 GPU machine, without training a giant LSTM? And they came up with the attention mechanism. And there are additional steps there that again involve people working in limited constraints that end up producing self-attention, that ended up producing the transformer. And there are actually a number of examples like this. And so again, that's the kind of optimism that I have to have in order to survive and I think do good work.
Yeah, you touch on this idea of working on the fringes, taking on projects that folks in industry with rich resources likely wouldn't be motivated to explore. Today in your lab, there are a few key areas that guide your research work, like furthering your seminal work in transfer learning, spearheading systems and methods for collaborative and continual model development. What other aspects, or what does that decision framework, that you use look like when you're deciding where to focus your efforts, and how this evolved throughout your career?
Yeah, definitely. I mean, one like very simple thing is that we don't end up working on projects that require a lot of compute because we don't have it. So that's like a very simple first step of like throwing out certain projects. We aren't going to be training any giant models from scratch in my group anytime soon, unless someone wants to give us a bunch of money. But I don't think that's going to happen anytime soon. So that's kind of like the simple first order thing. Realistically in my group, I try to have a mix of top down and bottom up, and the top down projects, the bigger projects that I want people to kind of work collaboratively on also I hope are built in a bottom up way. So, even the collaborative model training thing, that was kind of like an idea I had an inkling about, and I had a meeting with my earliest PhD students, with 4 students, and kind of saying, well, I'm kind of thinking about this, like, how do you think we can turn this into a research direction? And we all brainstormed it together. And I've done that a number of times, other research directions, even grants, I've had students like write the projects they want to work on, and I've integrated them into grant requests and so on. So a lot of it is bottom up. And I also reserve like a chunk of the research done in my group to kind of say, if a student really wants to work on something that's, I don't even know if it's a good idea, but they really want to work on it, it's just kind of exploration, then let them work on it. I have the privilege of being able to have some students exploring and some students exploiting, and have a good mixture in that respect. Now, all that being said, the other thing that I do that I think is relatively unusual, but I really actually like to do, is to literally rate research projects along certain axes, like what's the likelihood of the project to succeed? How much impact might it have? How likely are you to be scooped if you're working on this project? Why are you the right person to work on it? And a lot of the kind of questions or considerations I just mentioned align with some of those axes, right? Like if you want to train a giant model, why are you the right person to work on it? Well, you're not. So you get a 0 there, and maybe we shouldn't work on that project. And I think it's very rare to find a project that rates very high along these axes. But if at an individual level, if the student is kind of saying, look, like I'm in the beginning of my PhD, I just want to publish a paper. It's like, great, well, let's find a project that has a high probability of success, a relatively low difficulty, don't really care about the impact, hopefully not a high probability of being scooped, and you're relatively well suited to do. And we can find projects that kind of like fit that setting. And I don't know, that's worked pretty well for me. And I should say we literally do sometimes rate projects, like on a scale from 1 to 5, in order to help us make these decisions.
That's really interesting. I'm curious, how do you keep momentum in the building as a leader in your research lab? Continually cultivating the creativity to ideate and ask the right questions, and then working aggressively toward your research goals and targets.
Yeah, this is definitely something that I don't know what the right way to do it is. You could think about a professor who puts a ton of pressure on their students, like, oh, well, when are you going to publish this? When is this going to be done? Why isn't it working? Like all this kind of stuff. I tend not to work like that. I tend to try to be much more supportive, but also recognize that if I don't help them understand the importance of the work that they're doing, and the importance of like focusing on it and choosing the right experiments to run and so on, that they might not be as likely to succeed. So it's in both of our interests for me to help them understand, what steps they should take. And it's frankly, it's hard because research is hard. In particular, it's rare that a research project is obviously going to work. If it was obviously going to work, it wouldn't really be research anymore, right? It's just kind of, I don't know what it is. But one place that this comes up is, for example, if I actually really encourage my students to work on some particular project and it doesn't seem like it's working, then that's really hard, because I've basically said, you should really do this, like, spend your time doing this, and it's not working. And that's hard. And I think I just try to balance like the amount that I allow students to explore and focus on the things that are exciting to them, versus me saying, what I think you're excited about might not work. Maybe you should work on this other thing. And also just helping them understand that, the way that most research projects go is it doesn't work for the first 75% of the project, and then all of a sudden it works, and then the last 25% is running experiments and writing the paper. And that first stage can take a week, a month, many months, a year. So it can be really disheartening when you're banging your head against something and it's not working. And I think just helping my students understand that can happen and can be disheartening is kind of the best I can do.
Yeah, you've been vocal about how the development of ML models is still very much in the dark ages, and how we should work to move toward a world where we build models like we do open source software. And you spell out this idea in your piece, A Call to Build Models Like We Build Open Source Software. What motivated this perspective? And, as a community, what's key to fostering this ideal environment?
Yeah, definitely. So that, like I said, that research direction came from an inkling or a sense that I had that I then kind of fleshed out with my students. But the initial inkling came from my own background on working on open source software. When I was in high school and learning about electronics and how to build guitar pedals, everything I learned was just from people sharing stuff on the internet, saying like, oh, well, I built this circuit and it worked pretty well. And someone else says, oh, well, I changed this part and this worked better. So not even like an open source pipeline, but just sharing of knowledge and information. So that had a huge influence for me over the course of my PhD, especially where a lot of the work I did had to do with creating useful pieces of software for music and audio analysis, but also data sets and so on. To me, we make so much more progress via collaboration and openness than we do in any other way. That's just, I really fundamentally believe that. And there are really, really great examples of this in the software world, right? Like if you think about, people sometimes try to estimate like the value of open source software. And I think that's, it's incredibly difficult to do. And maybe it's not the right thing to try to do. But if you just think about, how many of the software systems we use are fundamentally reliant on pieces of open source software, like just like Linux, like basically every server we connect to on the internet is probably running Linux. There's a very high probability of that. And it's not that they're running Linux because Linux is free. It's because Linux is actually the best tool for running a server. And likewise, you could think about like the best pieces of database software are open source. And again, it's not because they're free, it's because they're the best. And we're just not anywhere close to that in machine learning, right? The best models right now increasingly are not publicly available. And and also they're not, they tend to not be continually improved, especially the ones that are out in the open. We basically build a new model and supplant the old model. We just kind of say, oh, this is the new model, it's better, that one is worse. And we've gotten pretty far in this mode of development, but I think we can get so much farther if we make it possible for us to continually improve a model together. We're used to, in machine learning, advances coming in steps, right? Like GPT-2, GPT-3, BERT, Roberta, whatever. But that's not how it has to be. We can make something, imagine rather than having everyone independently try to create a big step function and then one person wins, versus everyone adding a lot of tiny steps and we all win. And now we all have a model that's dramatically better. But the tricky and interesting part about this is that we actually don't have the research or tools to actually do this. So there are fundamental research questions that are hard and interesting and difficult to tackle that my students can write papers on. And the hope, is that 5 or 10 years from now, we'll look back on the way that we train models and build models and just be like, wow, why did we ever do that? That was so suboptimal. And we'll see if we get there.
Speaking of your students, what advice would you give to folks who are just starting their research journey?
Yeah, absolutely. I think, I've kind of touched on a lot of little pieces of advice that I often give, like, for example, the ways of picking a project by thinking about, impact and difficulty and all that kind of stuff. The fact that research is rarely a guaranteed thing. Sometimes it involves struggling for a while before things work. How to think about the projects that you're best suited to work on. The other thing that I like to think a bit about is to try for people to help identify in themselves what makes them excited or motivated to do research. Because I really think that some people are more motivated by curiosity. They like to work on problems that they think are like technically interesting and challenging. And in the most extreme case, they actually don't really care what impact it has. And you can imagine a lot of people where if they can just work on a juicy topic that like makes their gears turn in their head for a year, and then they publish a paper that no one ever cites, that's bliss for them, right? And on the other end of the spectrum, you have people who don't actually care about having their curiosity satisfied, but they just want to do work that changes the field or that changes the world. And thinking about what motivates you and where you fall on that spectrum, I think can be another good way as a heuristic to help you pick projects. And it also is a good way to identify collaborators, because there can sometimes be a little tension between these two things, like, picking a project that's exciting and helps you satisfy your curiosity versus a project that's impactful. And neither of those perspectives is correct, but it's good to have a sense of that. The other just really brief thing that I like to tell, especially like first year PhD students, is I think it's super normal and it's totally okay if in the first year of your PhD you kind of just switch around from topic to topic and don't really know what you're going to work on. A lot of people think that they should just jump into their PhD and immediately start publishing papers and being super successful because they've seen other people doing it, but I think that's an unrealistic expectation. The first year of my PhD, I worked on something that I didn't even publish a paper on. It's just a random thing that I thought was interesting and cool and promising, and I was wrong. And ultimately, I did good work during my PhD. But don't have such high expectations of yourself that you're just immediately going to find your 5-year research topic and start cranking stuff out.
Now, before we shift over to the Q&A portion of the chat today, I'm really curious, Colin, do you think you'll ever find your way back to music applications of ML?
Yeah, I feel like I've done a pretty decent job over the course of this chat of being optimistic and positive. The field of music in ML is so fun and exciting.
Mm-hmm.
And there's so many awesome people working there, because talking about like the motivation, people in music and ML are motivated because they really love music, or they play music, and those are such fun people to talk to and hang out with. Because as someone who really loves music and who used to play music, like like the flagship conference has like a jam session every year, and you have these outstanding scientists and musicians just rocking out together, and it's so much fun. But the sad problem with music and ML is that it's just relatively harder to get funding in. And again, I don't want to be super pessimistic, but you can't, there isn't as much money to be made in industry from music. I mean, sure, we have like Spotify, but and other like music recommendation, music creation apps, but the size of the business in making and analyzing music is just a lot smaller than a lot of like Vision or NLP, for example. So that's on the other one hand. The military won't fund it because you can't hurt people with it, and the NSF won't fund it because the NSF. I mean, the NSF will fund it, but the NSF tends to again try to find things that are not. It's art, right? Like in the U.S., we don't prioritize funding of the arts in general,
Right.
and that's really sad. But that's the sad truth, and as a result, fewer people tend to work in it. The field tends to be a little slower paced, which can totally be a good thing. But I found a lot of excitement from working in really fast paced fields where you have to work to kind of stay on top of everything. So that's like the very long and hopefully not too pessimistic outlook on it. The truth is that if I had a PhD student, especially a self-funded PhD student, who came to me and was like, I want to work on music. And sometimes, actually, even just the other day, I was thinking about like a cool music project for playlist generation. So if I had a student come to me, especially a self-funded student who said, I want to work on music and I'm interested in these kind of problems, or if a faculty at some other institution, because we don't have music people here at UNC, wanted to work on music projects and wanted to loop me in, I would be thrilled to. It's just that for these practical reasons, I ended up shifting away from it. But it is just so utterly fun. I mean, think about how fun it is to look at the outputs of a language model or Stable Diffusion, but think about how fun it would be to listen to music generated by a model. To me, it's just, it's incomparable.
Do you play any instruments today?
I used to play guitar. It's been long enough that I've actually played guitar that now I have to say I used to. It's probably been 5 or 10 years, just because as I got more busy with research and my family and everything, I played less. I also used to DJ a lot.
Whoa.
Yeah. And now I sometimes DJ at my friends' weddings, which again, it tells you the stage of my life that I'm at. And I also used to make electronic music. But now, honestly, I'm just like I just really, really love music. I love listening to music. I often, actually, I'm not doing it now, but I often have my headphones on for meetings because I'm literally listening to music during the meeting. And that's where I'm at. But I don't feel any bitterness about the fact that I'm not making music anymore. I just love music so much.
That's awesome. Well, maybe you'll have to DJ the Cohere party at NeurIPS next year. Awesome. Let's shift over to Q&A. We've got a lot of great questions in the chat here. Let's pick one of them to start out. Here's one question. Thanks for the session, Colin. Your career path is interesting as an advisor at UNC, where you get a multitude of high quality PhD applicants. What do you see in an applicant? What qualities you think help a non-standard candidate stand apart?
Yeah, definitely. So for me, I think unfortunately in ML and NLP and vision and all of these fields, there are so many strong applicants that a lot of advisors use dumb heuristics to try to figure out which ones to hire. And those heuristics could be like their GRE scores, which is a terrible measure. It could be the number of papers they've published, which is less bad, but still really bad. And because I know that I'm kind of, ultimately if a student is good, lots of people will notice they're good. I try to find the students who might not satisfy other people's filters that they're using, and as a result end up hiring people who maybe have like a less traditional background, or maybe are only on one paper, not as first author, which is perfectly totally acceptable, and it can be great. So that's like my personal angle. But then what I actually look for is, definitely the just general excitement and motivation for why they want to do research. And this is something that I tend to ask applicants. I also, especially recently, now that my lab has crystallized around certain research directions, I do try to find candidates who have a pretty decent interest in those directions, because like I said, if you characterize the work done in my lab as like collaborative model training as like one chunk of research, language models as another chunk, and then random stuff as another chunk, I don't want to hire a student who I know is just all going to be in the random stuff bucket. I want to find someone who at least aligns a decent amount with the other areas. And then finally, I want to find students who at least have a similar research taste to me, like they're interested, they're excited about the same kind of problems. Because, for example, I don't do any theory work. So if an applicant is like really excellent in theory and only wants to do theory work, I'm just not going to be that helpful to them. And I think they would be better off elsewhere. So those are kind of at least my perspectives. I'm trying to think if any of that is actually like helpful, actionable. Oh, the only like helpful, actionable thing is that if there actually is a professor who you are truly excited about them specifically because you know the work they do and you like it and it's important, then like write them an email about that. Like not even about yourself, because they'll see your application, but write them an email about the work they do and why it's important. And that's the best kind of contact that I can get from a student, for sure, for me personally. Yeah.
That's a great answer. Another question, what advice would you have for early stage researchers attempting to influence the efficacy of a new research agenda? So something that is new to the community and maybe not too many people are necessarily excited about at that given moment in time.
Yeah, it is a really hard question, honestly, because one of the, I mentioned skills that you have to develop probably over the course of your PhD, or just in general to become an excellent researcher, is the ability to vet projects, to think about, is this project, what's the probability of success, what's the level of impact, and so on. That's incredibly difficult. And, I used to think about like what people's hit rate was, like if I picked 10 projects to work on, how many of them are successful. And I think even the best, most incredible successful people have like a well below 50% hit rate. So first understanding that is important, and especially the less you kind of know or are aware of in the field, the kind of lower your hit rate will be. But I think the only two things that I can say that can be helpful are, to talk to people as much as you can, figure out what's exciting to them. That's a good sanity check. If you're the only one excited about it, maybe isn't that exciting. I try to avoid groupthink, and like jumping on the hype train. But on the other hand, like, people are often excited about things for good reasons. And then the other piece is, if you have a choice between 5 things that seem like equally promising, pick the one that you think you're going to be the most excited about and have the most energy for, because research can be a slog at times, and having the underlying motivation, like I said, is really important.
Someone asked, what is stopping or preventing the development of collaborative models? Is it an engineering problem or research problem that's the bottleneck here?
Yeah, the great thing is it's both, because that means there's lots of work to do. Because the truth is that if let's just throw out some examples. Let's say I have a shared model and you train it and I train it, and you want to send your changes back to me. Well, if you take a single step of gradient descent, you have to communicate the full model back to me. And if we have, like a 20 gigabyte checkpoint, we don't want to be passing back this giant checkpoint. So we need to figure out how to make patches, right? Or like commits, little incremental changes to models that are cheap to communicate, but still make the model able to do new things. And if you do some changes and I do some changes, now we have 2 conflicting models, right? We need to figure out a way to merge them. So how can we merge the models? Again, that's a research question that we don't have a perfect answer to. Or if I'm the maintainer and you send a change back to me, how do I know if I should accept it or not? How do I test the change? We only have kind of rudimentary ways to do that, like just evaluating it on tons of examples. And so those are the kind of the research questions, and all of them are important and interesting and hard. On the engineering side, we don't have, at least as of today, like a good version control system for incremental development of machine learning models. And that's one of the main things that my lab is working on now. Hopefully we have a system called Git Theta that sits on top of Git and basically keeps track of the parameters of a machine learning model alongside the code. And we're hoping to get it out in the next month or so. I will say that the way I like to think about this is that, under certain simplifying assumptions, we can avoid some of the really thorny research issues I mentioned. So we are hopefully, we as a field, or we as a lab, can start building models collaboratively and incrementally if we make certain assumptions, certain architectural assumptions, for example, while the research for the more general case is undergoing. And then once that research unlocks, a wider range of models, we can try using it on those models too. Yeah, that's why it's exciting, I think.
One more question before we wrap up. Someone asked, what are your favorite and least favorite things about working in academia? You touched on this a bit during the talk, but hoping you can expand on it before we close out the chat today.
Yeah. So, I mean, I think my favorite thing is probably the mentorship and just the challenge and rewards of that. But since I already talked about that, I'll say another thing that I really, really like is that it pushes you to constantly learn and push yourself outside of what your expertise and what you know. Because the great thing about PhD students, especially early PhD students, is they really don't know that much. So they get all these crazy, weird ideas. Like, a lot of them probably won't work and don't make sense, but they're not things that you would think of because you're kind of stuck in your way of thinking and the topics that you know really well. And that is really exciting. And also my students, they don't want to be stuck, at 5 or 10 years in the past. So in order to keep up with them and know, how to advise them and help them, I need to stay up on top of current research and on a wide range of areas. Because if I have enough PhD students and they're working on different stuff, in order to be helpful, I need to be able to cover all of them. So I like being motivated to learn and continually expand what I know. Least favorite parts. A lot of the stuff that I struggled with, I found ways. I think I'm just maybe like an overly optimistic or positive person, but one thing that I did struggle with was the fact that I mean, this could happen whether you're a professor or not, but it's at some point in your career, you might get to the place where you have so much stuff to do that in order to do everything, you have to spend as little time as possible on everything. And I have some like very extreme examples of that, like being like, oh crap, this grant deadline is in 6 hours. I need to write the proposal and I have 6 hours to do it. And that's it, right? Like it used to be like, oh, this grant deadline or this like whatever deadline is in 2 weeks. I'm just gonna like kind of mess around and blah, blah, blah. But so much stuff that I do, I just have to do like, or like I have a presentation I need to give. I have 1 hour to make the slides, like just dump them out. And I have learned to like grit and bear through that, you know, kind of like if you have to eat a food you don't really like and you end up liking it if you eat enough of it. But I'm I guess a little bit of a perfectionist. I like to dwell on things a little bit more. So that's wasn't my favorite thing to have to learn to love.
Well, thank you so much, Colin, for taking the time to speak with us today. Thought this was a lovely conversation. I learned so much, and I know so many other folks did too. For folks on the call, we'll be uploading this talk to YouTube later today, so you can rewatch at your disposal.
Cool. Well, thanks a lot for having me, Ellie. It's great to get to chat about this stuff with you. So yeah, I really appreciate it.
Awesome. Thanks, everyone.
Cool. Thanks, Ellie. See you later.